Okay, picking up with this problem, this may not be starting exactly where the last video left off because I noticed a mistake, so I was recording, noticed a mistake, so I stopped the recording and sort of started over. So this might not be picking up exactly where it left off on the previous one, but that's okay. We were to the point of trying to find the possible inflection points. That we had done all this horrendous work. We found the first, well, we simplified first, found the first derivative, and then I drew a line through the first derivative, said, not gonna need that anymore when I'm just doing concavity. A really common mistake is students will go back to first derivative information when we're doing concavity. When you're doing exclusively concavity, the only reason you write down the first derivative is to get to the second derivative. So we got our second derivative. And then we're to the point of finding possible inflection points. Second, possible inflection points come from two places, the second derivative being 0, second derivative undefined. So solving this guy, let's clear the fractions. So we multiply everybody by x to the 7th. Get some canceling here. So the first thing cancels, leaving that x cubed. On the next one, we get minus 5x squared. Then we get 8x. And lastly, we get minus 4 equals 0. And now we need to solve that equation. Now here's something I would never do to you on a test or quiz. Test or quiz, if I gave you something 4 terms like this that needed to be factored, it would factor by grouping. This one does not factor by grouping. If you remember all your high school algebra, there are other ways to factor things like this. We're not going to go into that because I would not do that to you on a test or quiz. So you're just going to trust me when I tell you that this factors to x minus 1, x squared minus 4x plus 4 equals 0. So you're just going to trust me on that, and hopefully I'm not lying to you. Then that factors again. And now I'm factored and equal to 0, so I can split that up. And I get 2 potential inflection points at 1 and 2. Now, inflection points come from 2 possible places. F double prime not existing. Well, if I go up here, and we'll rewrite it here, recall that F double prime is 1 over x to the 4th minus 5 over x to the 5th plus 8 over x to the 6th minus 4 over x to the 7th. F double prime does not exist at x equal 0. So there are 3 quote-unquote potential inflection points. Now for those of you that remember everything I say instantaneously, you might remember that I said up front that the original function was not defined at 0. And so that there's no point on the graph at x equals 0. So if we remember that there's no point on the graph at x equals 0, this cannot be an inflection point. Inflection point is a point on the graph. So this isn't automatic, it automatically is not going to be an inflection point. However, I still need it in my concavity chart that I'm about to draw. This, we're going to learn later, is going to turn out to be an asymptote, vertical asymptote. And at vertical asymptotes, concavity can change. And so this number, even though I know for sure it's not going to be an inflection point, it still has to go in my chart where I determine concave up, concave down. Just like I said when we were talking about increasing and decreasing, that you always had to calculate where that derivative didn't exist. That if your derivative was a fraction, you had to calculate that number where the derivative was going to be undefined. Maybe that number wouldn't be technically a critical number, but it was still a very vital number and still had to be in our calculations as far as increasing, decreasing. Same thing here. Even though we know this is not going to be an inflection point, it has to be in our chart. Now that being said, let's say it was a much simpler problem. And let's say you just had that was your second derivative. You solved that, you got x equal 1 and 2, and like half the class, if I just write instructions that say, find the inflection points. Up to half the class will do only this work and tell me that the inflection points are 1 and 2. And then they go happily along their way. No, possible inflection points. Just because the second derivative is 0 doesn't mean you have an inflection point. These might turn out to be inflection points, they might not. And so this will not be sufficient work to prove inflection. We've got to actually see that change in concavity. And so even though I'm warning you right now, not good enough to say inflection, these are just possible inflection points. Even though I'm warning you right now that this isn't good enough, up to half of you will do just this, stop and say you found the inflection points. Maybe you have, maybe you haven't. We have to see a change in concavity. So now, to go from this list of numbers, 0, 1, and 2, to finding actual inflection points, if we have any, we make a concavity chart. And so that's what we will go to next. So next, make a sign chart. For F double prime. And we'll go ahead and do that in another piece of paper. So, F double prime was 1 over x to the 4th minus 5 over x to the 4th plus 8 over x to the 6th minus 4 over x to the 7th. And my possible inflection points were 0, 1, and 2. Even though we already knew that 0 wasn't an inflection point, I'm just going to put it in there. So I make the same sort of chart that I did before. Negative infinity to 0, 0 to 1, 1 to 2, 2 to infinity. Test value. And like I said, some people like to do this on a number line, but it's all the same. And pick test values, negative 1, 0.5, 1.53, and plug into the second derivative. Now, I don't care how you come up with these signs, whether you use your calculator, whatever you do. I'm going to put it in my calculator. So I have 1 divided by x to the 4th minus 5 divided by x to the 5th plus 8 divided by x to the 6th minus 4 divided by x to the 7th. So I've put it into my y1, and then I'm going to do that same key sequence that I've done before. I'm going to quit that vars, arrow over to y vars, then it's a function, so 1, and then I put it in y1. And my first value I want to put in there is negative 1. And so I do that, and I get 18, which is positive. Again, that key sequence, vars, arrow over to y vars. It's a function, so number 1, I put it into number 1. And I want 0.5 this time. 0.5. And I get negative. Then if you don't want to hit all those keys again, you can just do second and enter. That brings back what you just typed, and then just put in what you want. I want 1.5. So 1.5. And that's positive. And the last one I want is 3. So second and enter and put in 3. And it does that weird thing. That's just scientific notation. So it really is 9.14494747 times e to the negative 4. It's scientific notation, but notice it's positive. That's all I care about. Positive. So there I have my signs. And so from there, I can say what's going on with my concavity. So f of x is concave, and then my second derivative is positive, so it's concave up. Then my second derivative is concave down. Then my second derivative is positive, so it's concave up. And then it's still up, still positive, so it's up. And so in the end, this is concave up on negative infinity to 0. I'll be perfect this time and put union symbols in there. And 1 to 2, and 2 to 3, 2 to infinity, not 3. And it's concave down just on 0 to 1. And we have an inflection point only at x equal 1. We already said that 0 was not going to be an inflection point because the original function was undefined at 0. So this is where you have to really remember things. Original function undefined at 0, no point on the graph at 0. So yes, we changed concavity, but not because we passed through an inflection point. It's going to be an asymptote. Here, there's not as good as change, so inflection point. And here, no change, so no inflection point. So I get an inflection point just at 1. With y equal f of 1, always the original function. And so plugging into the original function, that'd be 10 times 1 cubed minus 25 times 1 squared plus 24 times 1 minus 8 over 60 times 1 to the 5th. And what do we got there? 10 minus 25 plus 24 minus 8 over 60. So 10 minus 25 plus 24 minus 8. Type that in wrong. 10 minus 25 plus 24. Plus, my calculator is giving me problems. Plus 24 minus 8 gives me 1/60. I really should have been able to do that in my head. So I have an inflection point at 1/160 is my inflection point. And we've done all those calculations. And so there we've answered it. On the next video, because we're almost out of time, on the next video we will actually check this by looking at a picture. We just described where things are going concave up, concave down, whatnot. The next one we will check it on a picture.